Today's video, it's all about disc brake rotors again. This is the fourth melt, and what I'd like to know is just how fluid is that cast iron, but I suppose even more importantly is how soft can I get that cast iron so I can machine it either in the lathe or the milling machine. So what I'm going to do, I've got this sign. It is very thin and it's got the corners there and there, and those corners are usually always prone to chilling. So I'm interested to see how that one will come out if I'm able to machine it all over, but also more importantly in that corner. And the second mould I'm going to pour is this large flywheel. What I'd like to know is, can the metal flow from there through there and then fill up this smaller mould on the side, which will be joined just there. So we'll see how fluid that cast iron is, and also we'll see if we can machine this cover up. So while we're on the subject of covers, a viewer called Chirpy's Tinkerings, he made a comment on my last video and he said if you're going to cast thin section castings you would avoid using disc brake rotors. Well, you remember this one here, when I was machining it, it was chilled all around the edge. He might be right, but this is the idea of making or pouring so many different castings in different shapes, because you can't expect to have perfect castings every time. Somewhere along the line you'll turn up with a failure and then you have to figure out how to get around it. So this is what I'm going to do in this video. I've got the first two patterns covered. So for the next pattern, it's a very interesting subject, and what I'll do, it's worthy of a video on its own, so in the next video I'll cover that in far more detail. So what we've got here, this is the last mould I'm going to pour. There's two flywheels there. Now you'll know from experience, when you pour a crucible full of metal, it's nice and hot, but when you pour the last mould, generally the crucible's colder and the metal's even colder still, so it may not fill the mould. So what I'll do, I'll have a central point here, and what I'll do, I'll fill that one and then go over to that one as well, so it'll fill the two of them at once, and we'll see if they'll fill up. And that's the idea of this video. You do a wide range of castings, thick and thin and odd shapes, and to see if they'll work or if they won't work. So the box I'll be using today, it's made out of pine. I've used screws instead of nails because they keep splitting. But what I'd like to show you, this is just a rough sawn surface, and the distance between there and there is enough to hold that sand and won't fall out on you. So what I'll do, I'll show you how that distance from there to there is enough to hold that sand in. I'll pull the mould apart and reassemble it again on camera. As you can see, the sand didn't fall out. With that depth of 50 millimeters, that's all it's needed in there, and it'll hold the sand from there across to there. But if you make it twice that width from there to say here, what you need is a couple of braces across the top so the sand doesn't fall down. This is the plaque mould, very thin casting, looks like it filled up. This one is a flywheel casting, and boy was I lucky, it was just enough metal to fill up 2 flywheels, 2 small flywheels. This is the 4th disc brake rotor melt, and let's see what we've got. This is what we got this time. There's a tiny amount of chill on the left hand broken wedge, but it's a vast improvement over the last melt, so I might have to still add a little bit more ferrosilicon to get it completely grey. So what I've done, I've used a file and cut the edge of the wedge test, and it seems to cut in quite easy. That's a good sign, because I've got some fairly small castings where I've got to machine the edge, and we'll see how they turn out. This is the very first mould I poured. It's the plaque that failed last time when I put the clamp in the wrong place, and we'll see how it turns out. Looks like it turned out alright. Here is my toothbrush again. This is how easy the castings clean up. For this pour, I estimated for all the patterns that I'll need 13.7 kilograms. So it's a very fine margin of error if I underestimate. And as you can see, it's 10 millimeters from there to the top of the mould. Now this is what I spilt. Now I was trying to really concentrate and not spill a drop, but there's 2 pieces there, and if I had not spilt that, it probably would have filled up the mould. But anyway, enough talk. We'll see if this actually filled up, because this is the last part of the metal. It tends to be very cold, and we'll see if it filled up the mould or not. Nope, it just wasn't enough metal, and it was a bit on the cool side. Oh, better luck next time. Out of 7 moulds I poured, this one here was the last one I poured. Didn't fill up. This one was the second mould I poured. It's a flywheel, the same as that, and we'll see how this one turned out. There you go, did fill up. And also the metal had to flow all around there and even further into this cylinder cover. Worked out quite well. Here we are, we've got the failure right in front of the camera. So why did it fail? I know someone's going to pipe up and say, oh, you should have put air vents in the centre there, then it wouldn't have happened, it would have filled up the mould. Well, I'll just show you something. That failure casting was the last one. This one was the second poured. So you can obviously tell that this was a lot hotter, and when you pour them, where it's the first pour or the second pour, you'll get a really good casting. It'll fill up the mould, and you can see why, because it's got to go through there, through there, through there, and then over here, and it fills up even this mould right on the very edge. So what happens is, it's a failure of me to reschedule the castings and put them in the right place in the pouring order, and then it would have worked, but never mind. So what we've got to do, it's not a total failure, so what I'll do, I'll go and cut these off and put them in the lathe and see how well they machine. For me, this is probably the most interesting part of the video. I've machined the casting, and what happens is, a lot of the times there are defects under the skin, and you'll only see them when you machine them. So we'll have a look. So I'll rotate it around. Looking good so far. Yep, come out really good, and it machined well, this cast iron. But one thing I've got to say, most people don't understand how to machine cast iron. That is a very large diameter, so you've got to slow it down. And when you've got an uneven surface on a casting surface, you're cutting thicker cuts and probably thinner cuts, and you've got to slow the whole thing down a lot. And then when you've got good metal like that, then you can speed it up to get a good finish. So you're probably wondering why there's a texture mark there. See that there? I always do that because that's where the metal came into the mould, and that's where most of the time, if you find a defect, it's usually somewhere around underneath the skin in there, and only the machining will reveal it. So I've got another thing I was going to show you. Here's a file. Now, see the corners there, the edges, they're most likely to be chilled. So what I'll do, you can see where it's dug in there, it's nice and soft. That's how you can tell a casting is going to be good to machine even before you machine it. It'll give you a very good indication. So now I've got a close-up of the casting, and these edges are very prone to chilling, and you can see there's no chilling, and the same with the other side. There's no chilling. Here we are. This is the aftermath of the first attempt at casting the plaque, the workshop sign, and as you can see, it didn't fill up the mould. So why didn't it fill up? What happened? Before I usually pour, I usually run the trolley and the crucible over to make sure the clamps don't interfere with pouring. And it was very close, but I thought it would be good enough. But no, when I actually poured, I hit the clamp and couldn't pour. So you can see my vain effort there was a waste of time. I tried to reposition the trolley and pour it again, and what happened? Yep, it's a waste of time. Anyway, now I've got a good casting, so what I'll do, I'll machine the corners with the milling machine, and we'll see if they're nice and soft with a very thin casting. This is the first test for this casting. It's very thin, and it's made from disc brake rotors, and I'll see if I can drill the mounting holes. Yep, it's lovely and soft iron, drilled straight through it. So here is the close-up of what I milled on the milling machine. Yeah, unfortunately it is chilled around that corner there and it disappears about here. So how do we fix this problem? There's one way. You can see with the radius there, if you eliminate that corner, then you'll probably get good cast iron around there, not chilled. The other way, you're going to have to add so much more ferrous silicon, so the thin parts in that pour is going to be really soft. Here is the sign. It's been cleaned up with my belt sander that I made a long time ago. It's a very essential piece of equipment to use inside my foundry, and I can recommend anyone to either buy one or to make one themselves. So now just got to paint the sign to finish it. Ah yes, what a transformation. When this come out of the sand mould, it didn't look very special, but boy, when you put that coat of paint on there, it looks like $1 million. And also looking in hindsight, it did chill a little bit on the edges there. I could have drilled 4 holes in there and there and there and still would have worked. But anyway, I've done it now and it looks really great.